and welcome back to Elementary Algebra. I am your instructor, Amy Fuchsteiner, and we are going to talk about polynomials. There's a lot of little pieces to polynomials. You can see there is some vocabulary coming up. I've got like 10 different words here that we need you to make sure we need. 10 different words we need to make sure you're familiar with. Okay? All right, so let's get started on some of these ideas. A polynomial is an algebraic expression that is made up of what are known as several terms. So a term is a collection of variables and numbers that are held together by multiplication and division and separated by addition and subtraction. For example, if I have 2x plus 5, this is known as an algebraic expression in two terms. There are two terms here. Our first term is the 2x. The 2x contains a variable of x a coefficient of 2, and is known as a variable term. So basically, like we talked about in, I think, the very first chapter, the variables are stand-ins for unknown quantities. They're numbers that we might replace with a value later, but sometimes it's just a manipulative and it's meant to stand in for an unknown quantity. The coefficient, I think we've talked about as well. The coefficient is the multiplier in front of the variable. Most often it's a number. Sometimes that number can be a fraction or a decimal. If you don't see a number, then what we put in front of it is 1. So 1 is the implied coefficient when there's no other coefficient there. All right. 5, as you see all alone here, this 5, this is a second term. This is known as a constant. A constant is a number without a variable with it. It does not have any multipliers, not multiplying anything. It's just hanging out there all on its own. The value of that 5 will never change. It will remain constant. It will always be worth 5. And so this is why we call this a constant term. Okay, so we have in this particular polynomial two terms. The first term is a variable term with a variable of x and a coefficient of 2. The second term is a constant term, and it's simply 5. This is a polynomial in one variable because the only variable in the polynomial is x. We will also be looking at some polynomials in two variables, and a polynomial in two variable will probably look something, could look something like a negative 6x squared y plus 3xy plus 9y. This particular polynomial has 3 terms. The first term here would be the negative 6x squared y. This has 2 different variables. It has a variable x and it has a variable y. It has a coefficient of negative 6. This would be called a variable term. Okay. The second term here would be the 3xy. This, again, has a variable x. It has a variable y. Its coefficient is 3. That 3 is positive. I'm taking the sign from the plus here because there is no other. If there was a negative in front, I would say the coefficient was -3. But since there's no other signage, I'm taking the plus sign. My last term is the plus 9y. This is, again, a variable term. I have a variable here of y and a coefficient of 9. This is a variable term as well. Okay. I'm using just a V to substitute for writing out variable because otherwise my hand gets tired. We know if expressions are polynomials because there are some certain rules. Here's what you need to know. I'm going to explain by example, and hopefully you'll catch on to some of the no-nos here. So if we look at 1/2 a plus 5, this is indeed a polynomial. I have two terms, the 1/2 a and the 5, and those two terms are being connected by the plus sign. That's what holds them together as the polynomial. So this one, yes, is a polynomial. Okay. If I look at the second example, 5x squared minus 3x plus the square root of 8. This is also a polynomial. 5x squared is a variable term with a variable x and a coefficient of 5. Minus 3x is a second variable term with a coefficient of -3 and a variable of x. The square root of 8 is a constant term. That number will never change. Square root of 8 is square root of 8. I don't know what that number is. It's got to be less than 3, right? Because the square root of 9 is 3. And if this is the square root of 8, it's got to be close to 3, but less than 3. Okay? So yes, this is also a variable term. If we look, or a polynomial. It's a polynomial. If we look at number 3 looks like a polynomial, but it isn't. And the reason it isn't is because we have that negative exponent. That negative exponent breaks the rules of a polynomial. A polynomial cannot have a negative exponent. It can only have positive exponents, right? So that's the first rule that we broke. If we look at problem number 4, is that a polynomial? Well, yes. By all definitions, that is a polynomial. It's not a big polynomial. It's not the best example of a polynomial, but it is a polynomial. It doesn't have any letters or variables in denominators. So that works. If we look at problem number 5, is that a polynomial? It is. I have 3 terms there. My first term being the 4y to the 4th. It is a variable term with a coefficient of 4 and a variable of y. My second term is the -3y squared. Notice I'm taking the sign that was in front because I have no other indicator. So my coefficient is -3. My variable is y. I have a variable term. My third term is plus 6xy. I'm keeping the plus because I have no other indication. So I'm leading with the sign in between. I have 2 variables here, an x and a y. So this is a polynomial in 2 variables. And I have a coefficient on that third term of 6. If we look at problem number 6, I didn't answer yes or no. That's a yes. Problem number 6, is that a polynomial? Well, remember, I couldn't have a negative exponent because that put a variable in the denominator. Do I have a variable in the denominator here? I sure do. So this is also a no. This cannot be a polynomial. When asked why not, because we have a variable in the denominator. That's what ruins it for us. This m right here, that's in the denominator. Okay? All right. So I've said several, but can you list the terms of the polynomial? And if the term has a variable in it, list the coefficient. If we're looking at problem number 7, the addition and subtraction are what delineate or break apart the terms. So I have a term of negative 2x squared, and the coefficient is negative 2. I have a second term of 5x. The coefficient is 5. My third term is a negative 17. Doesn't have a variable on it. It won't have a coefficient. Negative 17 is my third term. There is no coefficient here. This is a constant term. Problem number 8. We have a 23x squared y to the 5th. That is my first term. Does it have a coefficient? Well, are there variables there? There are definitely variables, an x and a y. The multiplier of those variables is our coefficient of 23. Okay. Is there a second term? Yes. I have a negative 12 over 7 xy cubed. All of that multiplication and the division even holds that term together. I'm using the negative xy cubed because I don't have any other indication of sign. So that negative is my indication of sign. The multiplier, my variables are x and y cubed. The number in front is the negative 12 sevenths. That is my coefficient. The multiplier of the variables is your coefficient. All right. I think the next thing we have to do is talk about the idea between a monomial, a binomial, and a trinomial. Monomials, binomials, and trinomials are classifications of polynomials. So if it only has one term, then it's referred to as a monomial. If it has two terms, then we call it a binomial, and trinomial is 3 terms. If there are more than 3 terms, then we just call it a polynomial. If there's 5 terms, it's a polynomial. If it's 6 terms, it's a polynomial. If it's 27 terms, it's a polynomial. The only ones with special names are 1, 2, and 3. So these are classifications of polynomials. Just to be clear, it can be a polynomial if it's outside of this classification, but then we just call it polynomial, right? So if we have problem number 9 with 2x plus 9, you can see here, I hope that there is one term here and a second term with the plus 9. This would be a binomial. Right? If we're looking at problem number 10, we have a 9d squared, a plus 24cd, and a plus 16c squared. This is 1, 2, 3 terms. This would be a trinomial. For problem number 11, we have just a negative 16. That's it. That is a polynomial. It is a constant term. And since there's just one of them, we would call this a monomial. Monomials in particular can be deceiving because sometimes they're as simple as a minus 16, and other times they're as complicated as all of this together. Yes, there are 2 different letters here. Yes, there is a numerator and a denominator. Yes, there are many parts, but everything is held together with multiplication and division. There's no addition or subtraction here to separate out parts. So it's one gigantic idea. That makes it a monomial. I'm not saying it's not messy. I'm not saying it's not complicated, but it's one gigantic idea. Okay. All right. So, third thing to talk about is the degree of a term and the degree of the polynomial. So, the degree of the term and the degree of the polynomial, these have to do with the exponents. All right. Within a term, the degree of the term is the sum of all powers or all exponents within that term. So given a term, if you've got squareds and cubes and whatever all within that term, then the degree of that term is the sum of all of the exponents, right? If we're talking about the degree of the polynomial, the degree of the polynomial is the degree of the highest term. Okay. This takes a lot of getting used to. I'm not going to like sugarcoat this. This is going to take some practice. Okay. All right. So if we look at some examples just for the degree of the term, let's start there. Let's make sure we've got clear the degree of the term. So for number 13, we've got 24 q to the fifth r to the third. The degree of the term is the sum of all of the exponents within that term. So I have a fifth and a third. So the degree of the term this term is degree 8. It's the sum of all of the degrees within the term, all of the exponents within the term. If we're looking at problem number 14, there isn't an exponent there, or is there? X is the same as x to the first. So the only degree within this term is 1. This is degree 1. This is a monomial of degree 1. Okay? If we look at number 15, here we have a negative 4x squared y. X squared, there's a degree right there, or there's an exponent right there. And then on the y, we should have a 1. So this one would be degree 2 plus 1, which is 3. This is degree 3. Okay? Now, you should have noticed by this point that I'm not counting the degrees on the numbers, because I could write 2 as 2 to the first, and that would put a degree on that. But we only want, or a variable, oh, my words, that would put an exponent on that. I'm not counting exponents that would be on numbers. I'm only counting exponents on variables. So within a term, the degree is the sum of all exponents within that term of all variable exponents. Let's put variable in there. So we're going to say it's the sum of all variable exponents within that term. So what happens when we get a number like 16? 16 does not even have a variable on it, right? So 16 is degree 0 because there are no variables on it. Therefore, it cannot have an exponent. Well, and let's be honest, even if it did, let's say we had an x here, it would have to be x to the 0 anyway, right? Because x to the 0 is 1, and that wouldn't change the value of 16. So if you just have a constant, if you just have a number all alone with no variable on it, that is degree 0. Okay? So now that you know how to find the degree of a term, how do we find the degree of a polynomial? Well, for a polynomial, you have to look at each term. 2x, this is degree 1, plus 9, and we just said that that's degree 0, right? We just did that one. So this is degree 1. This is degree 0. What's the highest degree of any term? The highest degree of any term is the degree of a polynomial. So this is going to be degree 1. Right? Let's try another one. Okay. Problem number 18 has 1, 2, 3 terms. So if we look at the first term, we have 4y to the 4th. The second term would be a negative 3y squared. And the third term would be 6xy. There's my 3 terms. 4y to the 4th, we're only looking at the variables, is a degree 4. 3y squared would be degree 2. The exponent is the degree. If there's more than one exponent, we add them up. 6xy, the x is degree 1, the y is degree 1. So this would be degree, when there's more than one variable, we add the exponents. This would be degree 2. So you have 3 terms here, degree 4, degree 2, and a degree 2. Of those 3 terms, what's the highest degree? That means for this polynomial, it is degree 4. Final answer. Okay. Let's try number 19. Number 19 is a polynomial with 1, 2, 3, 4 terms. The first term has 2 variables in it. One has an exponent of 2. This other has an exponent of 5. To get the degree of this term, I would add those exponents together. This is degree 7. The second term has a degree of 1, has a variable with an exponent of 1 and a variable with an exponent of 7. To get the degree of this term, I will add them together. It's degree 8. The third term only has 1 variable in it with an exponent of 9. So this is degree 9. And the fourth term has only 1 variable in it with an exponent of 10. So this term is degree 10. Of the 4 terms, which one has the highest degree? So degree 10 is the degree of the polynomial. Okay. For doing problem 20, this is a trinomial. I have 1, 2, 3 different terms. The first term is a variable term with only 1 variable and an exponent of 2. So this would be degree 2. The second term is a variable term with 2 variables in it. Each of those variables have an exponent of 1. That would make this degree the sum of those exponents, or 2. 1 plus 1 is 2. The third term is a variable term with only 1 variable and an exponent of 2. So this would also be degree 2. Of these 3 terms, the highest degree of any of the terms is 2. So the degree of this trinomial is degree 2. Wouldn't matter which one, because they're all the same. Okay? All right. The third part of this is evaluating polynomials. We talked a little bit earlier about what a function is, and we're going to talk some about polynomial functions. So what do you need to know? Well, remember, a function is continuous and it doesn't jump or skip, right? And the function notation is just a way of saying if we test this function at a value of x, then what we get is. So basically what we have for number 21 is that f of x, this function at x, is the same as if we had taken a negative x squared and added twice x and then subtracted 5. They want to know what's going to happen if x is negative 2, if f is 0, and if x is negative 2, if x is 0, and if x is 4. So what we're going to start with is what happens at f of negative 2. What this means is we are letting x equal negative 2 within the polynomial. So instead of a negative x squared, I'm going to put in a negative 2 and square it. Instead of a 2x, I'm going to put in a negative 2. And then I'm going to subtract 5. So I'm going to have a negative 2 and a negative 2. That negative 2 is going to go in wherever the x was in this polynomial. So I'm going to have a negative 2 squared. That's negative 2 times negative 2. That's 4. But then I've got a negative on the outside. So that's going to be negative 4. Plus 2 times a negative 2 is another negative 4 minus 5. That's a negative 8 minus 5, which is a negative 13. Then I'm going to try f at 0. That's going to be a negative 0 squared plus 2 times 0 minus 5. So that's going to be 0 plus 0. 2 times 0 is 0 minus 5, which is a minus 5. Then I'm going to see what is the function at 4. So that's going to be a negative 4 squared plus 2 times 4 minus 5. What is that going to get me? Well, 4 squared is 16, but I have to put that negative on, so that's going to be a negative 16. Plus 2 times 4, that's 8, minus 5. Negative 16 plus 8 is a negative 8, minus 5 more. Yeah, I'm getting a negative 13 again. Okay, so I have determined the value of this polynomial function at each of those values. A negative 2, a 0, and a 4. Okay, h of d, so the function h at d, if d squared plus 13 is the polynomial we're talking about. So we're going to do h of a negative 15 is going to equal a negative 15 squared plus 13. Well, if I square 15, that's 225. A negative times a negative is a positive. So this would be 225 plus 13, which is 238. And if I do h of the second one, which is 0, that's going to be a 0 squared plus 13. Sorry, I jumped the gun there. 0 squared plus 13, which is 13. And then if I do h of a positive 15, that means I'm putting positive 15 in wherever there was a d. So instead of d squared, this is going to be 15 squared plus 13. And I already told you 15 times 15 is 225. So that's going to be 225 plus 13, which is again 238. And I found each one of those values. I have evaluated. All right. Now I've got one with fractions because, well, basically because fractions shouldn't be quite as scary as they are sometimes. I get that they are. It's okay. All right. So I've got f of c is 1/4 c to the 4th, 1/3 c squared, and 1/2 c squared. Okay, let's go. So I need to do f of negative 2, which means I'm going to put a negative 2 in wherever there was a c. So this is going to be 1/4 of a negative 2 to the 4th plus 1/3. Oops, I didn't want to do that. Negative 2 squared. I think I meant for that to be cubed. I bet I meant for that to be cubed. I'm going to switch that to cubed. So that's going to be negative 2 cubed plus 1/2 a negative 2 squared. Okay, I'm going to put my negative 2's in now. That should have been a negative 2. That should have been a negative 2. Okay, negative 2 to the 4th. Negative 2 to the 4th. It's negative 2 times negative 2. That's 4. Times a negative 2. That's a negative 8. times a negative 2. That's going to be a 16. So this is going to be 1/4 of 16 plus 1/3 of negative 8 plus 1/2 of 4. Okay, I'm not done. There's a lot here. 1/4 of 16 is 4. Yep. Plus 1/3 of negative 8. I'm just going to write it as negative 8 over 3. Plus 1/2 of 4 is 2. That's going to be 6 plus a negative 8/3. What's 6 times 3? That's 18. So that's going to be 18 over 3 plus a negative 8 over 3. Or 10/3. If you're not very confident with fractions, feel free to use your calculator, right? Because your calculator has a fraction button. Use that to help you if you need to. So I'm going to do 4 plus negative 8/3 plus 2. So I get 3 1/3. Yeah. So to convert that to an improper fraction, if needed be, that's a second, and then the ABC. And that'll write it as 10/3. Or you can write the mixed number and do the mixed number if you know how to convert yourself. Okay. What about f of 0? Because that's our next one. F of 0 is going to be 1/4 of 0 to the 4th plus 1/3 of 0 to the 3rd plus 1/2 of 0 squared. Oh, I love this. Don't you love this? Because what's 0? What's anything times 0? So that's going to be a 0. 1/3 times 0 is 0. 1/2 times 0 is 0. And if I add a bunch of zeros up, I just get 0. I like getting zeros. And the last one is f of 2. So that's going to be a 1/4 of 2 to the 4th plus 1/3 of 2 to the 3rd plus 1/2 of 2 to the 2nd. So 2, 2, 2. That's going to give me a 1/4 of 16 again, plus 1/3 of 8, plus 1/2 of 4. Well, that's almost exactly what I got before. That's going to be 4 plus 8/3 plus 2. The sign is different on that. So 4 plus 8/3 plus 2. I get 8 2/3. 3 times 8 is 24 plus 2 is 26. 26 over 3. I don't know if I need it to be 26 over 3 or 10 over 3. I don't know if I'd need the whole number. I wouldn't want the decimal here. That's the only thing I would tell you, is that you probably don't want the decimal because it's a 3, so the decimal's not going to end. It's going to be a 0.33333333333 or a 0.66666666666. So you won't know how many places. So it's just easier to do the 1/3 and the 2/3. Okay? All right, so hopefully that sets you up with some vocabulary, because the next couple of sections that we're doing in 5.5 through 5.8, you will need it. If you have any questions, please don't hesitate to reach out to me or drop into the Math Center. Julia is there and more than willing to help. Thank you all so very much. You have a good night.